electrophilic substitution reaction in benzene, specifically sulfonation. This is today's lesson. In this lesson, we are going to learn reaction between benzene and sulfuric acid to form benzene sulfonic acid, then electrophile hydronium ion and sulfur trioxide, and finally mechanism of the reaction. So let's begin. The first point is reaction between benzene and sulfuric acid. Let's write the reaction. This is benzene. Each corner of the hexagon benzene, that means 6 carbon atoms carry 1 hydrogen atom each. When this benzene is treated with sulfuric acid, then 1 hydrogen atom is replaced by sulfonic acid group. This is sulfonic acid group. This hydrogen breaks away as electrophile, and another electrophile, sulfur trioxide, bonds to this carbon, and as a result this ion is formed, and after that this ion combines with proton produced from hydronium ion in the reaction. When it bonds to this ion, then we get SO3H, benzene sulfonic acid. Here this hydrogen is replaced by sulfonic acid group, and as a result benzene sulfonic acid is obtained, which is known as sulfonation. The reaction in which hydrogen atom is replaced by sulfonic acid group, then the reaction is called sulfonation. This reaction is carried out at 100 degrees Celsius temperature. Let's see the next point. Electrophile hydronium ion and sulfur trioxide. In this reaction, which one acts as electrophile? This is the point now. Let's see. This is hydronium ion, which is positively charged. This is positively charged electrophile, and sulfur trioxide is a kind of neutral electrophile. But in this reaction, hydronium ion cannot act as electrophile in this way. Oxygen atomic number 8, electronic configuration is 2p4. If this electronic configuration is drawn in box method for the outermost shell, then we get, this is 2s, 2p contains 4 electrons, 1, 2, 3, 4. So oxygen has no vacant orbitals in its outermost shell. That is why oxygen atom of hydronium ion cannot accept one pair of electrons. That is, it cannot act as electrophile because it has no vacant orbital in its valence shell. So in this reaction, hydronium ion, positively charged entity, cannot act as electrophile in this reaction. Now let's see about sulfur trioxide. Sulfur trioxide, electronic configuration of sulfur is 1s2, 2s2, 2p 6, 3s2, 3p4. Up to 3p, 16 electrons have been arranged. But in this case, electrons are distributed up to third energy level. Third energy level contains 3 sublevels, 3s, 3p and 3d. So here 3d sublevel that contains d orbitals. Those orbitals are vacant. No electrons are in these orbitals. So in case of sulfur trioxide, sulfur has vacant orbital in its valence shell, and this is structural formula of sulfur trioxide. Electronic configuration of oxygen is 3.5 and sulfur is 2.5. Because of the higher electronegativity of oxygen, covalently bonded pi electrons move towards oxygen, and as a result, oxygen gets negatively charged, sulfur gets positively charged. Because of this positivity, with its vacant orbital, sulfur trioxide receives one pair of electrons. That is why sulfur trioxide acts as electron acceptor, that is, it acts as electrophile, receiving one pair of electrons. But in case of hydronium ion, oxygen has no vacant orbital in its valence shell. That is why this positively charged entity cannot accept electron pair. So hydronium ion cannot act as electrophile, but sulfur trioxide, sulfur gets positively charged and it has vacant orbital in its valence shell, by which it can accept one pair of electrons and it acts as electrophile. But in case of hydronium ion, that splits up into proton and water. This proton can accept one pair of electrons. This proton acts as electrophile, which is produced from hydronium ion. So simply, in sulfonation, hydronium ion cannot act as electrophile, but sulfur trioxide acts as electrophile. Let's move on to the next point. Now the point is mechanism of the reaction. Let's write the reaction first. Benzene, sulfuric acid. This mixture is heated at 100 degrees Celsius temperature. Then this hydrogen is replaced by sulfonic acid group and water vapor is produced as byproduct. This is benzene sulfonic acid. Now let's see reaction mechanism of the reaction step by step. Step 1, sulfuric acid molecule, another sulfuric acid molecule. That means every 2 sulfuric acid molecules react with each other at 100 degrees Celsius temperature, and then sulfur trioxide, hydronium ion and bisulfate ion are formed. This reaction happens in this way. Oxygen, sulfur, oxygen, oxygen, hydrogen, oxygen, hydrogen. Another sulfuric acid molecule, hydrogen, hydrogen, which is heated at 100 degrees Celsius temperature. Then one sulfuric acid molecule releases this hydrogen as proton. This proton combines with this water molecule which is produced from another sulfuric acid to form hydronium ion. And from this sulfuric acid molecule, bisulfate ion is formed, and from this sulfuric acid molecule, sulfur dioxide is produced. Let's see the second step. Step 2. This sulfur dioxide, which acts as electrophile here, but hydronium ion cannot act as electrophile in this reaction. That has been explained. Here, this is benzene, which is electronically rich, and this is electronically deficient. Positivity is created over sulfur. So benzene donates electrons to sulfur of sulfur trioxide, and as a result this is formed hydrogen, here sulfur trioxide. As sulfur trioxide receives electrons from benzene, that is why here positive heat is created, and at the same time over sulfur negative charge is created, because sulfur trioxide receives electrons from benzene. For this reason benzene ring gets positively charged, which is called sigma complex, and sulfur trioxide gets negatively charged because it received electrons from benzene ring. And after that, because of this positive charge, covalently bonded electrons of carbon and hydrogen move toward benzene ring, and this hydrogen is freed as proton, which combines with bisulfate ion, which is produced at the first step. So it combines with bisulfate ion to form sulfuric acid again, and here this ion is produced. Now this ion at step 3 receives proton, which is produced from hydronium ion. Hydronium ion is produced at step 1. So at step 3 this ion receives proton, which is produced from hydronium ion to form SO3H. This proton combines with this ion, and as a result benzene sulfonic acid is formed, and from this hydronium ion water is formed. So through these steps benzene sulfonic acid is produced and water is produced as byproduct. Here sulfur trioxide gets positively charged in this way: sulfur, oxygen, oxygen, another oxygen. Oxygen's electronegativity is higher than sulfur. Covalently bonded pi electrons move towards oxygen. It gets negatively charged, sulfur gets positively charged. This positive charge over sulfur. Because of this positivity, sulfur trioxide receives electrons from benzene. Because of the reception of electrons from benzene, this positivity reception of electrons from benzene, this positivity is diminished and it remains as a negative charge. This negative charge, sulfur trioxide with negative charge. This is all about sulfonation in benzene. No more today. Thank you very much.